am Dr. J. Kavita, Assistant Professor of Chemistry, V.V. Vaniya Perumal College for Women, Virudhunagar. And in this video lecture, we can talk about electromagnetic radiation. First of all, we must know what is electromagnetic radiation and what is the purpose of electromagnetic radiation. Why this electromagnetic radiation is very important means this is the basic of spectroscopy. We can determine the structure of any molecule with the tool known as spectroscopy. There are different types of spectroscopy. We can have UV spectroscopy, IR spectroscopy, NMR spectroscopy, ESR, EPR. There are so many types of spectroscopy. What all the different types? The basic one is electromagnetic radiation. That is the source of spectroscopy, we can say. So what is electromagnetic radiation then? It is nothing but the electromagnetic radiation comes from any source of light. So how this spectra is related with electromagnetic radiation is when we have an atom or molecule, we pass this electromagnetic radiation over the atom or molecules. So this electromagnetic radiation is going to interact with the matter. As a result of this interaction, the matter can absorb or it can emit this electromagnetic radiation. As a result, it gives the result as spectral lines. So the spectral lines can be interpreted, and from the spectral lines we can analyze the structure of any molecule. So the basic of spectroscopy is we have to pass an electromagnetic radiation with matter so that the atoms or molecules present in the matter can absorb this electromagnetic radiation or it can emit this electromagnetic radiation. As a result of this absorption or emission, it gives out as spectral lines. Analysis of the spectral lines gives the structure of the molecule. Fine. Now we can see what are the characteristics of this electromagnetic radiation. Electromagnetic radiations are having beautiful character, that is, it behaves a dual character. What do you mean by dual character? It possesses two characters. One is it can act as a particle as well as a wave. Dual character of electromagnetic radiation, it is acting as a particle as well as a wave. Now here we have to emphasize one point. When it is acting as a particle, it obeys Einstein's equation, that is E is equal to mc square. So m is mass of the particle, so that we can say electromagnetic radiation is behaving like a particle according to Einstein's equation. Again we can stress electromagnetic radiation can behave like a wave. So when it is behaving as a wave, it obeys Planck's equation, that is E is equal to h nu, where h is Planck's constant, nu is frequency. So that these two definitions or these two expressions clearly indicates that electromagnetic radiations possess dual character. And also we can say electromagnetic radiations travels with velocity of light. Its speed is equal to velocity of light, that is represented as c. C is equal to 3 into 10 power 10, 3 into 10 power 8 centimeter per minus 1, or it is 10 power 10 meter per minus 1. So that we can say an electromagnetic radiation, when it is made to pass on a matter, the matter absorbs the electromagnetic radiation, and this absorption is interpreted in the form of a spectral line, and so from the spectral line we can analyze the structure of the compound or molecule. Next we are insisting about the electromagnetic radiation regions. See here we are having different regions. This electromagnetic radiation, we can have gamma ray, X-rays, UV rays, infrared rays, microwaves as well as radio waves, and of course in the center we are having visible region. So electromagnetic radiation possesses different types of frequencies starting from 10 power 2 to 10 power minus 4 when it is represented in wavelength scale. When it is represented in the frequency scale, it ranges from 10 power 8 to 10 power 22. So when this electromagnetic radiations of greater frequency or wavelength is passed on a matter, what happens? The matter absorbs the radiation. This we have already seen. As a result of this absorption, there will be different types of transition. Sometimes the molecular rotations occur. Sometimes nuclear spin occurs. Sometimes there will be change in the valence electron. Sometimes there will be change in the molecular vibrations depending upon the frequency. So here we have clearly shown the spectral region, gamma rays, X-rays having different frequencies. If it is X-ray, it will have only the frequency range between 10 power 16 to 10 power 20. Now we come to the special point about our visible region. Visible region, of course, you would all know that it has a VGR starting from violet to red. So here it starts from the wavelength 380 to 780. So when this type of electromagnetic radiations having different frequency or different wavelength is made to pass on a particle, depending upon the particle's nature, they will absorb particular frequency. And as a result of this particular frequency absorption, it will undergo a special type of transition. This is the basic of electromagnetic radiation concept. Again, we have shown here the different regions of electromagnetic spectrum. See here, it is represented in different scale. It is represented in different scale. We can mark it as wavelength, lambda. We can mark it as frequency, gamma. So when I talk about this wavelength scale, I can say between the region of 10 power minus 2 to 10 power minus 4, that region is called as NMR region, or that region frequency is known as radio frequency range. When an electromagnetic radiation is passed on a matter, if the atoms or molecules absorb such radio frequency ranging from 5 to 100 megahertz, what happens? It will result in the NMR spectrum. And suppose if the molecule is absorbing the wavelength between the range 5 into 10 power 2 to 4 into 10 power 3 scale, then there occurs vibration of the molecule. As a result, we get infrared spectrum. So depending upon the absorption of electromagnetic radiations between different scales of wavelength, we get different spectra. We can get Raman spectra, we can get electronic spectra, we can get ESR spectra. So different type of spectral analysis or spectral arrangement is because of the absorption of electromagnetic radiations by the atoms or molecules present in a matter with different scales of absorption. So very beautifully this picture is depicted, saying that electromagnetic radiations are having different types of frequencies. When a matter or atom is absorbing a particular frequency, we get a particular spectrum. So if it absorbs microwave scale of frequency 10 power 0 to 10 power 2, then we get only the rotation spectrum. This is the very basic beautiful concept of electromagnetic radiation. And of course, now we come to the point. We are passing an electromagnetic radiation. The matter or atom has absorbed that electromagnetic radiation depending upon different frequency. Okay, fine. Now what happens to the atoms or molecules? Because of this absorption of electromagnetic radiation, the atoms or molecules will undergo transition between different energy levels. So when we go to the different energy levels, what are the different types of energy levels? We are having three different types of energy levels. We have three different types of energy levels. We are having electronic energy level, we have vibrational energy level, and of course we are having rotational energy levels. Electronic energy level can represented by the formula E. Vibrational energy level, it is represented with the formula V, and rotational energy level is given with the formula J. So every atom is having different types of energy level: electronic energy level, vibrational energy level, rotational energy level. Now next question, how these energy levels are arranged? So we can see this is the electronic energy level E. So this is the lowest electronic level with energy E1, and this is the highest energy level with E2. So we are having two largely spaced electronic energy level. Between each consecutive electronic energy level, we have vibrational sublevels that is marked as 0, 1, 2, 3. That is, I can have it as V equal to 0, V equal to 1, V equal to 2, V equal to 3. This is the lowest vibration energy level. This is the highest or upper vibrational energy level. So to differentiate the lower and higher vibrational energy level, it is usually to represent this energy level with single prime and double prime. So the lowest energy level is marked with a single prime and the highest energy level is marked with double prime. So V double prime equal to 0, V double prime equal to 1, V double prime equal to 2. So by this way we can mark this vibrational energy levels. So now again I am stressing the point, when an atom or molecule is absorbing an electromagnetic radiation, it undergoes transition. The transition can take place between electronic energy level or vibrational energy level or between rotational energy level. So the electronic energy level is the highest spaced energy levels. Between two electronic energy levels there are so many vibrational energy levels, and next between any two vibrational energy levels we have the rotational energy levels. Very closely spaced lines it is represented. So between two electronic energy levels there are so many vibrational energy levels in the lower state as well as in the upper state, and between any two vibrational levels we are having very closely spaced rotational energy levels that is marked with the term J. So of course I can have the lowest level as J equal to 1, then J equal to 2, J equal to 3, etc. And again I am stressing the point here, when it is in the lower state I can mark it as J prime. When it comes to the upper state I can mark it as J double prime. So these are the ways in which the energy levels are arranged in a molecule. Again I go to the previous slide. See here, I have marked it as microwave, infrared, visible and UV. And here I have marked it as electronic, vibration, rotation. What is the relation between these two? Now from the second slide we have talked very clearly about a molecule is having an electronic energy level. Each electronic energy level is where it is having vibrational levels, and between every vibration levels we are having a rotational levels. So if a molecule absorbs, listen carefully, if a molecule absorbs visible and UV range of frequency, if a molecule absorbs a frequency between the range 10 power 3 to 70 into 10 power 3 centimeter square, then there occurs electronic energy level transition. Got it? Similarly, if a molecule absorbs a radiation between 5 into 10 power 2 to 4 into 10 power 3 per centimeter of wavelength of light, then that is infrared region. So by the absorption of such a type of infrared frequency, the molecule will undergo a transition between the vibrational energy levels. And if a molecule absorbs a microwave wavelength from 10 power 0 to 10 power 2 centimeter power minus 1, then that type of microwave absorption results in rotational spectrum. So different types of spectrum occurs as a result of absorption of different types of electromagnetic radiations. We can say UV and visible frequency. If a molecule absorbs such a frequency, it undergoes electronic transition. If a molecule absorbs infrared frequency, then it undergoes vibrational transition. If a molecule absorbs the frequency between the range of microwave region, then it undergoes rotational transition. Depending upon different types of arrangement or absorption, we can have different types of transition. So that can be an electronic transition, or that can be a vibrational transition, or that can be a rotational transition. So this absorption and emission is clearly shown here. A molecule in the lowest state can absorb, it can go to the highest state, and similarly a molecule can from the highest state it can come to the lowest state. So this slide clearly shows about the absorption and emission spectroscopy. So in this video lecture we have clearly talked about what is electromagnetic radiation, how this electromagnetic radiation forms the basis of spectroscopy, and as a result of this electromagnetic radiations, how we are getting the different types of transitions, electronic, vibration, rotation. Thank you.